Sulphur forms a large number of oxo acids. Many of these do not exist as free acids, but are known as anions and salts. Oxo acids of sulphur, depending on their structural similarities, are divided into 4 series. They are sulfurous acid series, sulfuric acid series, thionic acid series, peroxo acid series. Oxo acids with SS linkages are called thioacids, while those with peroxo linkages are called peroxo acids. The table here shows the names, structures, and oxidation states of sulphur in its various oxo acids. As you can see, sulfurous acid, di- or pyrosulfurous acid, and dithionic acid are categorized under the sulfurous acid series. Sulfuric acid, thiosulfuric acid, and di- or pyrosulfuric acid are grouped under the sulfuric acid series. The thionic acid series includes dithionic acid and polythionic acid, while the peroxo acid series includes peroxomonosulfuric acid and peroxodisulfuric acid. Among these oxo acids, sulfuric acid is the most important acid used in the chemical industry. It is manufactured by the contact process. The contact process involves 3 steps. The first step is the production of sulfur dioxide. This can be made by burning sulfur or sulfide ores, such as iron pyrites, in excess of air. The second step is the formation of sulfur trioxide. Sulfur dioxide is oxidized to sulfur trioxide with atmospheric oxygen in the presence of vanadium pentoxide as catalyst. The third step is the conversion of sulfur trioxide into sulfuric acid. The sulfur trioxide formed in the second step is dissolved in 98% sulfuric acid to give pyrosulfuric acid or oleum. Oleum is then diluted with water to give sulfuric acid of the desired concentration. The plant used for the contact process is shown here. The plant includes pyrites burners or sulfur burners, dust precipitator, washing and cooling tar, drying tar, arsenic purifier, preheater, catalytic converter, and absorption tar. Let's briefly discuss the different stages involved in the manufacture of sulfuric acid by this process. The sulfur or iron pyrites are burned in the sulfur burner to produce sulfur dioxide. The impure sulfur dioxide and oxygen gases from the sulfur burner are passed into the dusting tar, where the dust particles are removed by settling down. The purified gases are now passed into the washing and cooling tar. Here, the gases are cooled and washed. The moist gases from this tar are passed into the drying tar. The gases are dried by a spray of concentrated sulfuric acid. The dry gaseous mixture from the tar is then passed through the arsenic purifier. The main impurity in the gases arsenic oxide, is removed here. The pure gases are passed through a preheater and heated to about 673 to 723 Kelvin. Gases are then led into the catalytic converter. Here, in the presence of vanadium pentoxide as catalyst, sulfur dioxide and oxygen combine to form sulfur trioxide. The sulfur trioxide is then led into the adsorption tower. In the absorption tower, sulfur trioxide is absorbed in concentrated sulfuric acid to form oleum. The oleum is diluted with water to get the acid at the required concentration. The key step in the manufacture of sulfuric acid is the catalytic oxidation of sulfur dioxide to sulfur trioxide with atmospheric oxygen. The forward reaction is exothermic and is favored by a low temperature. Since there is a decrease in the number of moles of gas, the process is favored by a high pressure. Hence, low temperature and high pressure are the favorable conditions for maximum yield. However, the temperature should not be too low, as the reaction would then become slow. In practice, the reaction is carried out at a pressure of 2 atmospheres and a temperature of 720 Kelvin. The sulfuric acid obtained by this process is 96 to 98% pure. Let's now look at the physical properties of sulfuric acid. Sulfuric acid is a colorless, dense, oily liquid with a specific gravity of 1.84 at 298 Kelvin. It has a boiling point of 611 Kelvin. The high boiling point and viscous nature is due to hydrogen bonding, because of which a number of simple molecules bind together to form a cluster. Concentrated sulfuric acid has a strong affinity for water. A large amount of heat is produced when the acid is mixed with water. The temperature may rise to as high as 393 Kelvin. Hence, the acid is always diluted by adding it to water slowly with constant stirring. Remember, never add water to sulfuric acid. The evolution of heat is due to the formation of hydrates such as H2SO4, H2O, H2SO4, 2H2O, and H2SO4, 4H2O. Let's now study the chemical properties of sulfuric acid. The chemical reactions of sulfuric acid are due to its low volatility, strong acidic character, strong affinity for water, and ability to act as an oxidizing agent. Sulfuric acid is a strong dibasic acid. In an aqueous solution, it ionizes in 2 steps, as shown here. Note that the value of dissociation constant, Ka1, for the first step is very large as compared to the second step. The larger value of Ka1 indicates the greater extent of ionization of H2SO4 into H+ and HSO4-, which in turn indicates the greater acidic strength of the acid. The acid neutralizes alkalis and forms two series of salts, bisulfates and sulfates. For example, concentrated sulfuric acid reacts with sodium hydroxide and forms sodium bisulfate and sodium sulfate, as shown in the equations here. Sulfuric acid, being less volatile, is used in the manufacture of more volatile acids from their corresponding salts. For example, concentrated sulfuric acid liberates hydrogen fluoride from calcium fluoride, and hydrogen chloride from sodium chloride. Concentrated sulfuric acid is a powerful dehydrating agent. The dehydrating property is used in drying many wet gases that do not react with the acid. For example, gases like chlorine, sulfur dioxide, and hydrochloric acid are dried by passing them through sulfuric acid. Sulfuric acid also removes water from organic compounds like carbohydrates. For example, it chars sugarcane, glucose, and starch to carbon. Hot concentrated sulfuric acid is a good oxidizing agent. It oxidizes both metals and non-metals and itself gets reduced to sulfur dioxide. For example, hot concentrated sulfuric acid oxidizes copper to copper sulfate and gets reduced to sulfur dioxide. Similarly, it oxidizes non-metallic carbon to carbon dioxide and itself gets reduced to sulfur dioxide. Lastly, let's look at the important uses of sulfuric acid. Sulfuric acid, because of its wide applications, is referred as the king of chemicals. It is used in the manufacture of fertilizers like ammonium sulfate and superphosphate, dyes, pigments, and paints. Explosives such as TNT. Other important chemicals like hydrochloric acid, nitric acid, phosphoric acid, and sodium carbonate. It is used in the refining of petroleum. Sulfuric acid is also used as a pickling agent. Pickling is an industrial process for removing layers of basic oxides from metals like iron and copper before electroplating, enameling, soldering, and galvanizing. As a laboratory agent and a dehydrating and oxidizing agent,